One of the things I hope you learned from today's lesson when we were motioning graphs, when we were graphing our motion, we were doing all this stuff with the carts, we had a lot of different shapes to look for. But the shapes that I think are most important for you to remember what the shapes look like. The shape depends on what's on the side. So it's important to understand over here, sometimes we have displacement and time, and sometimes we have velocity and time. And so the shape is going to change depending on what's happening. If we are traveling at a constant speed, then what's going to happen is at a constant speed, we're going to get a nice direct relationship between displacement and time. But if we're traveling at a constant speed on a velocity time graph, it's going to be a nice flat graph like this. Now, in reality, of course, we're going to have uncertain data and our lines aren't going to be perfectly straight like this. They won't even be perfectly flat. But we're going to have this type of relationship. You're going to see overall that this is what we see. So if we're traveling at more or less a constant speed, we should expect a straight line on a displacement time graph and a flat line on a velocity time graph. It's flat because on the velocity time graph, our velocity isn't changing. If we're traveling at a constant speed, then it's not going up or down. We're traveling at a nice flat slope, the slope of 0. So these are what it would look like if we are traveling at a constant speed. On the other hand, if we are accelerating, what you're going to find is that on that same displacement time graph, if we're accelerating, or a velocity time graph, then the shape is going to change. So in the displacement time graph, what we're going to find is we get an exponential relationship. And so you will see a curve. Sometimes the curve isn't quite as obvious as you wish it would be, but you'll still see it's curving this direction. And so with a velocity time graph, then we would find that we have that direct relationship. So these two graphs are going to look similar if you're not careful to look at what is on the side. They're both going to be direct relationships, that nice linear relationship that's going up and to the right. But one is saying the speed is increasing, that's going to be the acceleration one, and one is saying the displacement is increasing, that's going to be the constant speed one. So again, the ones on the left are really talking about constant speed. And so a displacement time and a velocity time graph are going to look like that. And over here, of course, we have acceleration. So an acceleration graph is going to look like that and like that. So you should know that both of these on the right are showing the same type of motion, and the ones on the left are showing the same type of motion. These are not showing the same type of motion. They have the same shape, but they're not showing the same type of motion because one is velocity and one is displacement. So even though they have a similar shape, they're not actually showing the same type of motion. So you need to be able to distinguish between these types.